Hey, I'm George. I'm the co-founder and CTO of Spotter. Today I'm going to give a walkthrough of Spotter. Firstly, we'll start with the case study of one of the fintech applications that we have scanned using Spotter and move on to logistics tech application. Then I'll explain the working of how Spotter does. To start with, I'm starting with the fintech application, which is in the microservices architecture. So we were able to find cross-service authorization vulnerabilities in this fintech application. This application in particular, it was already done the standard security audits, and it's a live production core. We were able to find two critical findings as a cross-service vulnerabilities. It's a cross-service authorization gap, particular data component, where you can see here the customer data component imports and uses the IDS order component without validating that the current user wants the data being accessed. So this is basically a multi-tenant access vulnerability. So how it can be attacked, like how can we get the data out of this? So when a URL is uploaded, a URL is given, the customer ID is passed and the own customer sees his data. But when the URL modifies with a different user ID, with a different token, again he is able to find the data. So here, if you could see, there was no customer check found in the customer ID. The ownership check was not done. So it has become a vulnerability, and currently the data is exposed. The financial portfolio, the investment orders, the transaction history, account details are all open for it can be accessed externally. Again, like the same vulnerability in a different place. So this also the ideas order component implicitly trusts the URL parameter without re-evaluating the current user is the owner of that customer record. So yeah, this is almost like it is the same ownership issues, but it is from the backend. So it has to be fixed from backend as well. So it has to be fixed from both the front end and backend. So basically, it's a trust boundary violation that it has caused. And here are the detailed explanations that we are taking out. So this current case study we have taken out from the exact summary that has been generated by a document, and we have added more context just for this demo. You can see how doing the exploit validation here as well and how we are confirming. So we are validated in backend as well. So here the detailed proof of concept of the attack that can happen. Yes. And I'll move on to the next application. It's a logistics application which is in a monolith architecture. This particular application is the live production code, but the only difference is like it didn't go through active security audit, but we have done an internal SEMGREP findings and we were not able to find the vulnerability Spotter could find. So basically, these are business context based vulnerabilities which would actually cause the breach. So if you could see, we were able to find 136 vulnerabilities where 87 are high priorities and 49 are medium. I'll just take you through what it was able to find. So there are vulnerable endpoints identified based on the open. Uh, there is no authorization checks for all of these vulnerable APIs. So these are mentioned here. And what is the main type of vulnerabilities? I'll just show you. So first scenario is FAQ injection and data corruption. Since the APIs are open, there is no authentication required, and it can be a vulnerable data injection that can happen, and there can be data corruption. And second vulnerability type is insecure IDOR issues. This is specific to business logic because like the loads and trip access are limited to the specific customers, but it Spotter was able to find there is a multi-tenant isolation gap where anyone can access any load trip data. So that is what it has been mentioned here. Broken access control and either access to competitor loads is attack scenario that can happen. And vulnerability three, it's the same business logic level vulnerability of a tenant isolation. Again, broken access control. Anyone can access anyone's trips here. So that is what has been mentioned here. Yeah, so the attack scenario is like you make an false trip and trip completion can be done. So the next one is cross entity authorization failure. So the entity is like that the ownership of one particular entity can access the data owned by other entity. So that is what is being done. Multi-entity data leakage can happen. So, and finally, again, the multi-tenant isolation gaps. The validation of multi-tenancy is not happening in most of the places. So there are like multiple APIs which can be exposed to this. So it has been given the root cause analysis as well, code level issues. What are all the code level issues that can be recommendations, suggestions has been given, and other missing configurations in the code base, and all the business compact analysis. Again, this document was generated using the report generated by Spotter, and we've added more LLM propagation to this. So these are all like generated content. So yeah, so it has given a plan to fix these issues as well, and also suggestions to fix these issues. And yeah, so this is all about it. We are giving recommendations and suggested fixes. So I can go ahead and explain how it is being done. So with Spotter, what we are doing is we are generating a high level design configuration for the context so that our AI agents can find vulnerabilities specific to your tech stack and business context. So this is one of the HLD config that we have generated particularly for the fintech application. You can see our AI agent was extracting the architecture types and the services. If you could see the different services, like since this is a microservice architecture, there are multiple services. It was able to find all these and also find the entities related to it, like what are all the entity does it own and what is the role of that particular service that we're using. You can check here and you can see here like how many entities that does each service own. So we are doing entity propagation to get the proper context, and we are also doing like after this we also do risk profiling service. A lot of services here. Let me scroll. Yeah. So then we have this shared entities. So this is going to be the context for all the services, which is propagating how each services are reaching out to other services, how the communication between other services work. So this is being generated, shared entities of each services, and also how does the authentication work and how does authorization work, how does it work in each and every entity is being done, and what are all the sensitive patterns, what are all the PIS. It was all extracted from the code using our code extraction agent. So this particular context is used then to generate a custom rules for the application particular to that application. So what does or how does this rules look like? So I'm giving you an example of the rules generated for logistics application. This will be generated based on the context generated earlier. So this is for a different application. I'm just giving here for example. So we generate custom rules to be found, which will be used by the specialized AI agents to find vulnerabilities in the code base. Then, so it is able to fetch and generate specific to the business context and specific to the tech stack. It was able to generate 77 rules, and the rules types are like all these: authorization 44, input validation 15, authentication, rate limiting, and data protection. So these are the layers that we use for scanning. So these are some of them, and yeah. So we have each rules like the authorization related rules are on the top, and it propagates to every other rule. So you can go through this here, and these are then passed on to our specialized agents to find vulnerability. So we have created close to 9 specialized agents to find different vulnerabilities in the application. So these rules are custom generated for the application specifically, and we are able to find VAPT level vulnerabilities